Hello everyone. So today we are giving you a demo of our truly wireless healthcare monitoring solution. So what benefit it provides it's in a real time. It takes all the data and show it on the cloud. So it helps in real time live remote monitoring. So what you will see here is, what we have done is we are uploading the ECG data which is live connected from the patient, and immediately you can see it on the cloud portal. Okay. So first, if you see here, in this we have a device which we call ECG front end. Second, we have a simulator, and third we have a Android app which is open now. So using Android app, the data is transferred from the device to the Android app through Bluetooth, and from the Android app to the cloud through 3G connection, 3G or 2G or Wi-Fi connection. Now I am starting the Android app. Device is already on. So first time when Android connects to the device, it will reboot the device, okay, clean it, then it will connect. So it has already sent a clean command to the device, and we are it's trying to connect to the device and start capturing the data. So as of now, the device is not connected to the patient, it is connected to a simulator where we are transmitting a ECG of NSR rate 80. Okay, so now Android app is connected to the device. On the device you can see one orange and one blue light blinking. The orange one represent like device is working, and blue one represent that Bluetooth connection is in place. You can see on the mobile that data is getting collected from the device. So this is the device icon, this is the mobile, and this is the cloud. So data is coming from the device to the mobile and from mobile to the cloud. Here we have option to see the ECG on the mobile also. So this is a specific permission required. So all patients will not be able to see this. This is a doctor login who will be able to see the ECG. So now you can see the ECG on the mobile. This is a normal 80 beats per minute ECG that you are seeing. Okay, and same will be shown on the cloud. So we are logging into the cloud portal, which is a cloud platform we have developed. So this same ECG will be showing here. So we have just started collecting, and you can see it is already loaded in the cloud. We just wait for the data to load the website. So you can see the device, and you can see the time here, which is 12:51, and the same time you are getting on the cloud. So it's the same data, it's exactly the same time data that is getting displayed on the cloud. Now I am changing the ECG waveform and selecting one of the arrhythmia conditions from the simulator. Okay, I am taking trigemini because the waveform is different and it gets immediately verified. Okay, so you can see immediately the trigemini waveform is coming on the mobile. Okay, within 10 seconds you will see it on the cloud also. You can see now it has changed to trigemini. So it's almost real-time data. You can get it on the cloud, from where the doctor can do the remote monitoring, or any hospital staff can do the remote monitoring for the patient. Okay, and you will also see immediately the new event in the event column. You will see that a new event will get detected. This event gets updated after every 1 minute. So we just have to wait, because it is already processed. So our algorithm, which is running on the cloud platform, is already detected. So now you can see it's retry Germany. It is already detected. Can you go to that event? So it will specifically measure where the event has happened. So that it will identify with a red mark. So it will, the logic is it will check for few beats and will confirm that event has happened. Okay, so it has checked for 3 beats. So continuously after 3 beats, this arrhythmia condition is happening. So it has confirmed that arrhythmia condition has happened. Okay. So it's very easy for the doctors to verify that this arrhythmia condition has happened. Okay. Now I am changing again to one more condition, which is called bradycardia. Okay. So for bradycardia, I will just put the rate to 30. You can see on the mobile, immediately it will change to 30. So you see the peaks are happening at 30. Okay. The same thing will change on the cloud web portal. So you can see the arrhythmia is changed to 30 beats per minute. Okay, and our algorithm must have already detected the thing. You will see the new event ready in the new events tab. So that detection is done by the algorithm running in the cloud. So you see that acute brady is detected. And we can see the event. Acute bradycardia, where exactly it has happened. This shows the complete 1 minute data. So it has happened at this place. So it has detected the acute brady. Okay. We'll go back to ECG dashboard. I am putting it to 150. So immediately it will change on the mobile. And the same thing you can see in the cloud. So you can see it has changed to acute brady with a BPM of 150 beats per minute. Okay, and same way the event will also be detected for tachycardia. So with this, there is other things that is collected by our ECG devices. Front end is respiration rate and activity data. As of now, device is resting on the table, so activity is sedentary, and it also shows the HR rate. So full day chart for Holter monitoring, live Holter monitoring, you will get it here. You can use this for 1 day, 20 days, 15 days, 30 days in case of event or MCT, or even for a longer term. Okay. So now this was data collected from the simulator. Now we will collect it from the connecting it to the body. So here you can see like all the 8 channels can be seen on the cloud live. So chest lead 1 and chest lead 2 is also getting detected. The gel pads can be attached to the body like this. So it hardly takes 2 minutes to take the ECG using our device. One more feature is the moment I disconnect the leads, immediately it will be shown on the mobile and mobile will beep. Because leads are off, so even if a single lead is disconnected, it will show that lead is disconnected. Connecting the RL lead is mandatory. If RL lead is not connected, then other leads will, even if it is showing connected, it's a false indication. So first I connected RL, and you will see like slowly the cross sign will disappear. So you see now the leads are connected to the body. So give some time for data to stabilize, electrodes to stabilize. I can hang the device like this, or I can also keep this one in the pouch attached to the belt. Anything is fine. So currently I am hanging it. Now you can see the data has somewhat stabilized on the mobile. Same thing you can see on the cloud. So now on the cloud you can see the data. So this is the real patient data that is getting collected. So during changeover procedure some noise will come, but otherwise data will be clear. So this data is connected and it is uploading, and you can see, and I can move with this ECG with this device connected to the body. And it will keep uploading the data. So why I am moving is to show that that there is activity that is happening. So there will be change in the activity. And data will keep getting transferred to the mobile. So it's not like necessarily that mobile has to be in the pocket or this. You can keep it for charging and it will keep updating, collecting the data. If it is Bluetooth is out of range for a minute or two, still it will keep collecting the data. Device will keep storing the data, and whenever Bluetooth comes in range, it will be transferred to mobile and then to the cloud. And like this I can wear the device under my shirt and t-shirt. So I can wear comfortably the device below the clothes for the long term monitoring and do my normal work. So it's a very easy to use device for real-time Holter monitoring. There will be minor motion artifacts that will come because of the skin movement. If the person is lying, then it will be very smooth. If person is moving, then because of the skin stretching and this, minor motion artifacts will come. You can see if I go out of range, something like 10 at more than 10 meters and above, you will see in the mobile it will show that the device is out of range, and when I come back it will show that it is connected. It went out of range, and when the person came back within the range, it is again connected, and it will also transfer all the stored data, so there is no loss of data. Also the data is stored on the mobile till it gets transferred to the cloud through 2G or 3G connection. If in some place 2G or 3G connection is not there, data will be stored on the mobile and it will be transmitted later. So data is transferred 3 times faster when it is stored. Okay. So suppose you are out of range for 12 hours, so you need at least 4 to 5 hours to transfer the complete data back to the cloud. But for the real time monitoring, the patient has to be within the range of the mobile. So algorithm settings, we can do it from here. Like doctor can do these settings. So we are in the doctor login now. So for Brady, what is the minimum BPM you want to set? For acute Brady, what is the minimum BPM? For tachycardia, for ventricular tachycardia, for pause, when it has to be detected. So these all settings will be taken by algorithm, and accordingly it will process the ECG data and detect the arrhythmias. So our algorithm is tested against all the MIT database, and it's 100% validated with respect to the MIT database. Okay. Here we also have notification criteria. This is the criteria done, should be put in by the doctor. Okay. What is the criticality of a particular arrhythmia and when he want to be informed. So the technician who is, if you need a, if there is a setup, call center setup where the all the arrhythmias are monitored before it is seen by the doctor, because doctor will not be monitoring every time. So there is a backend team required, which we call it technicians, who will be seeing the arrhythmia detection and inform the doctor whenever there is a critical arrhythmia happen. Though our device is not an emergency response device, but through this setup, if any of the critical arrhythmia happens, technician can inform the call of the doctor. Okay. Now coming back to reports. So doctor can generate the report for daily. We can open one of the report and up-to-date report, and there will be end of service report. Okay. So after the service is ended for full day monitoring, so it will automatically detect all the reviewed events, okay, by the doctor, which doctor wants to be sent in the report for the later analysis. So this is how the report will look like. So it shows the complete 24-hour HR rate graph, heart rate graph, respiration rate, activity level. Okay. It will also tell the event summary, onset of events for duration. Okay. AFib burden, bradycardia, duration. So this is how the report generated by the system will look like. So this is the screen for a technician. So technician will see all the events like this. And one more big thing, like thousands of patients can upload the data simultaneously to our system. So it's fully scalable. Cloud platform is fully scalable, okay, reliable, and it complies to all the HIPAA and DEPS requirements. Technician screen will look like. So this is how the technician screen will look like. So he can select, he can crop any part of the ECG and okay, select this one. So it can come here and he can provide its comments, and this is the screen that will go for doctor review. So he can select as many screens as possible from, anyway it's only 1 minute strip that he sees, which is iterative algorithm, so 2 or 3 steps is good enough. And there is a caliper function here which measures from which distance to which distance it has to. And here the technician can also see all the patient info, okay. And here also timer is there because he has to finish the review within a limited period of time. If he doesn't finish, it will automatically log out from his screen. Okay. And he can accept or reject the event, whatever is detected by the algorithm. Once the event is accepted or rejected by the technician, automatically the new event will be loaded for the technician. He doesn't have to go and select and things. So just to save the time, automatically default event or high priority event will be loaded. Event is accepted or rejected by the technician, it will load the new event for the technician. And he can keep doing this continuously till the backlog is cleared. So this complete cloud platform is put on the IBM software cloud, which is fully scalable and reliable, and we will be providing it complies to the HIPAA requirements and DEPS requirements. It's completely secure and scalable and reliable, and reliability is provided across the zones, okay, that is taken care of by the cloud implementation and design.